Alright guys, we are going to do number 5 here. A position time graph for a particle moving along the x-axis is shown in this figure. Find the average velocity in the time interval between 1.5 seconds to 4.4 seconds. So this is pretty straightforward, folks. We're just going to be looking at this graph, and this thing is asking to find the average velocity. Now before I go further, folks, I want you guys to emphasize this. When it's asking for the velocity, that implies the direction. So since this is a one-dimensional problem, this is just the x-axis. This implies in whatever direction, sideways, tilt, horizontal, whatever that direction x is, and it could be anything. If it's moving positive, that means it's going towards the right. And if it's moving negative, it's going towards the left. Not always. It's usually based on the way you traditionally. This is just the way we traditionally model this, but realistically, the traditionally is you can really change it however you guys want. So keep that in mind. And I know I could make this video a little shorter, and I probably should make it shorter, but I also want to emphasize one thing, folks. Since we're given the shape of this graph, right? We're given this shape, this parabola looking shape. I want to emphasize one thing. If it's asking for the average velocity, let's say this is the point at 1.5, and actually let me change that. Since this is the time axis at 1.5 seconds, and the point at 1.5 seconds, it looks like it's going to lie here at 8 meters, and the point here is at, what's that, 4 seconds, and that's going to be at 2, so let's say 4. I know this is not to scale, but I never draw them to scale. I'm generally lazy on that, but anyways, that 4 meters. Realistically, think of these as, when you're finding the average velocity, think of these as points. Like, think of this as, what is the velocity between these points? Because realistically, we know this is going to be a parabola that's going to look like this. We know that. But pretend that that shape doesn't exist, and we're just like emphasizing really the points when it's asking these. Now, if it's asking for the instantaneous velocity between this, or maybe to kind of average the, take more of the average and make these 2 points next to each other. In fact, it doesn't even have to be these points. It could be on the side points for all we know. Then that's when we can start to infinitely make these 2 points next to each other to the point where it can start to become a tangent. That's all the base of calculus is. And I did just took an edible just now. Anyways, so find the average velocity between these points for 5 and 4 seconds. All right, let's find that. All right, so the average velocity is right here. So when x is, so it's really the difference between the heights here. So the difference between the heights is going to be 6 meters. And the difference between the x here is going to be, oh my god, I messed up. Okay, that's okay. It's going to be whatever that 4 minus 1.5 is, which is 0.5. That's 2.5 seconds. And that's it, folks. The average velocity between this is going to be the change of position over the time interval, and this would be 8 meters minus 2 meters over the course of 4 seconds. I'm just writing it off for you. I know I already solved it, but for 5 seconds, or you could just look at this graph. This would be 6 meters divided by 2.5 seconds, or this is going to be 2.5 seconds. That's half of 5, so that's going to be this. So the velocity is going to be 2.4 meters per second. And realistically, that's all they're asking. Determine the instantaneous velocity at 2 seconds by measuring the slope of the tangent line shown in the graph. All right, folks. I know the answer at the top of my head. And actually, I forgot to put that negative in there. Forgive me for that. That should be a negative. I don't know how I organized it. I messed up somewhere. But I'm not going to backtrack. I'm just going to leave it the way it is. Make sure you put the 8 minus I think I put 4 minus a 2 as opposed to 2 minus 4, or I did something backwards. I wasn't really paying attention. I was just looking at the bank, and forgive me for that. I'm a shitty tutor. What can I say? So determine the instantaneous velocity at 2 seconds. The 2 seconds is going to be at whatever the slope of the tangent line is. That's going to be the instantaneous velocity. So I'm going to say that's going to be maybe 13 over the course of 3.5. So maybe 13 over the course of 3.5. I'm going to put that in the calculator. I got approximately 3.517. When I did this on my own, I had like maybe 4. So, but I'm gonna put what the answer says. So however you approximate this, it should be something close to this value, because I say approximate because maybe these tick marks don't line up where they should be, and that's very annoying. But whatever. All right, we're done. At what value is of t is the velocity 0? So that implies when the change of position is 0, folks. What is the change of position? Well, isn't the change of position right here when the slope is right at 0? So the time value is going to be at 4 seconds. And we're done. Pretty straightforward. I don't know. I thought this was blue. I don't know. Sometimes they're blue, sometimes they're not. I don't really care. Anyways, folks, I hope you enjoyed.